When processing massive data sets in the R programming environment, iterating row by row creates an immediate computational bottleneck. The standard programming instinct is to write a sequential for loop to step through the data, one element at a time. However, in our specific memory environment, for loops require the system to repeatedly reallocate memory on every single pass. This adds severe computational overhead and balloons execution times. The solution is a shift in how we approach the data, applying an operation to entire data geometry simultaneously. In Base R, this concept is implemented through the apply family of functions. These tools collapse bulky multi-line loop constructs into a single optimized line of code. But this design prioritizes mathematical flexibility over strict safety. When live data behaves unpredictably, these flexible functions often adapt by silently altering the data type rather than halting the process. Writing reliable code in R requires understanding not just how to map functions efficiently, but how to guarantee the structural integrity of the resulting output. The foundational apply function requires the programmer to explicitly define the geometric slice of the iteration using the margin argument. Setting margin equal to 1 instructs R to slice the dataset horizontally. For navigating through deeply nested, multi-tiered lists, R provides Rapley, which recursively applies a function down through the hierarchy. In Base R, iteration is a structural problem. You must constantly swap the syntax, choosing between apply, lapply, or others to match the shape of the data entering the function. Because lapply always returns a list, the output can be bulky. Base R offers sapply as a convenience wrapper, designed to simplify those outputs automatically. If the returned elements are mathematically uniform, sapply coerces them into a clean, flat vector. Consider a script iterating across 3 database tables to extract the maximum numeric value. Under normal conditions, it extracts uniform numbers, and sapply collapses them into a single numeric array. Now suppose the third table goes offline, returning a character string error instead. Rather than halting, sapply accommodates this single text anomaly by secretly coercing the entire array of numbers into a character list. This silent type change is a failure point for automated pipelines. Text values pass through, breaking downstream mathematical operations without triggering an explicit error warning. The strict, safety-first alternative to this is vapply. Vapply requires the programmer to provide a strict output template, such as numeric 1. If the incoming data violates that template by returning text, vapply immediately halts the code and throws an explicit error. Relying on auto-simplification sacrifices operational stability. Explicit type checking is a requirement to prevent these silent logic failures. Iteration often requires grouping data by logical categories rather than purely geometric shapes. Base R handles this with tapply. The index argument within tapply acts as a grouping variable, sorting data into discrete buckets before calculating summary statistics. If you are analyzing a data set of animal weights, you use the index to group those measurements by distinct time intervals. The output of tapply is mathematically correct, but it generates a multidimensional array. We contrast this directly with the dplyr package. Dplyr handles the same aggregation by chaining group by and summarize commands. The difference is the output. Dplyr generates composable data frames. These connect directly to downstream filtering nodes, while the tapply array sits isolated. When logic requires processing multiple variables simultaneously, Base R provides mply. Mply passes parallel, disparate vectors into a single function. It executes the operation on all first elements simultaneously, then all second elements, and so on. These Base R functions handle complex logic, but their variable output formats, arrays, lists, or coursed vectors, create friction when building continuous data pipelines. The PER package provides a unified framework designed to standardize iteration syntax and enforce type stability. The translation from Base R to PER is direct. Map replaces lapply, while map2 or pmap handled the multivariate operations of mapapply. This framework eliminates the ambiguity associated with sapply. Instead of guessing the output, you use explicit variants like mapdbl or mapchur. These functions fuse the flat vector convenience of sapply with the strict safety constraints of vapply. Because the PER package strictly standardizes all of its outputs, its functions pipe seamlessly into one another using the standard R pipe operator. This leads to a clear rule for data analysts. Restrict the use of base R iteration to ad hoc, isolated scripts where speed of writing outweighs long-term pipeline stability. For heavy, production-grade analytics pipelines, where linear readability and continuous data flow are necessary, always use dplyr and PER. Finally, never deploy SAPLI in automated environments. The risk of silent type coercion is too high. Mastering data operations in R means moving beyond inefficient loops and adopting strict functional mapping. This ensures your transformations are as programmatically safe as they are mathematically precise.